All right, how's everybody doing today? Good, yeah. All right, cool. So today what we're doing is extraction of caffeine from tea. So definitely one of the staples of my life, caffeine in particular, but I like tea, coffee, um, obviously Red Bulls and the yerbas as well, but other energy drinks, whatever you got to do to get that fuel going for your mind and soul and your body to keep you going with all the hard work that we got to put in for this class, especially. So today, what we're doing is we're actually extracting caffeine using methylene chloride. So methylene chloride is an organic substance. We've seen that before in previous labs. We know that it's not miscible with water, and so we're able to extract caffeine from the water because it is, remember, more soluble in methylene chloride than it is in water, having that 4.6 value for the distribution coefficient. And so that's pretty much what we're using in order to isolate caffeine in its pure form. At the end, what we'll do to purify it even further is do a sublimation. So sublimation is definitely a new technique that we're going to be showing you today. Super fun. Basically, remember, sublimation is just converting your solid materials directly to the vapor phase. So it skips over that liquid phase, and so that's what the definition of sublimation is. You might have seen this either with iodine or maybe even more commonly outside of a lab with dry ice. So dry ice is carbon dioxide solid that goes directly from the solid to the gaseous carbon dioxide. So cool stuff. Love sublimation. It's a fun concept and fun thing to observe as well. And so the way we're going to do that in the end is basically reduce the pressure by putting the caffeine in a vacuum environment, and then we will also increase the temperature, so we'll heat it up as well. Okay, but some fun facts about caffeine first. So caffeine is about 5% of this tea bag right here by mass, and so caffeine's been around since like forever. I don't really have references for the information or anything, but read that basically caffeine was discovered back in the day, which was probably a Wednesday, and then some guy was observing that his goats were particularly frisky after having eaten this plant with red berries. So that's it was later named Caffea arabica. We also, that was like in AD 900 or so, but tea has been used in basically around China or like Eastern Asia, even like in BC, believe, but it is documented in like AD 300 where it's in an actual like Chinese dictionary, and so we've been using this stimulant since day one, pretty much, right? So like forever. And it is an alkaloid, meaning, so this particular caffeine structure does contain nitrogen, and it is a basic nitrogen, so it is an alkaloid by definition. It's naturally occurring with that nitrogen. So you can find it in cola nuts. You can find it in, obviously, coffee, tea, some mate leaves, get that yerba, right? Guarana seeds, we have guarana, you see that in like your Monsters probably, or your rock stars. And then obviously cocoa beans, so chocolate, right? So basically, I think the first time it was isolated was in 1821, a really long time ago, right? So the process isn't really that hard. It's super fun to do it though. And I do want to kind of tell you a little bit of information about, so the class of caffeine, it really looks like adenine, and it's in a class called xanthines. And so caffeine looks structurally similar to something called theobromine as well as theophylline. So these are all essentially some sort of stimulant, central nervous stimulant, but they have different level of effects on our body, and almost like just different they affect different areas of our body. So like theophylline is the heart, theobromine, don't remember. I think it's like heart and lungs for both of those. Obviously caffeine gets us going, right? It gets your heart pumping as well. Fun fact though, chocolate, the main xanthan in that is theobromine, and that's why dogs can't have chocolate, because of theobromine. So remember, keep the chocolate away from your pups. It is actually toxic even to us. So I think you would need about like 6 grams though. And I don't know about you, but I like to look at like how much caffeine is in like a Monster or something. It's so I think it's only like 160 milligrams in a Monster. Similar to a yerba, maybe even like 120 milligrams in that. A small Red Bull's 80 milligrams. A cup of coffee, like a standard cup of coffee, like the lame, like maybe Toll House or whatever, like the old school stuff that your grandma might buy. That's probably like 60 milligrams per cup of coffee, but I think a cup of coffee is technically like 6 ounces, right? Who drinks 6 ounces of coffee? Get out of here. Maybe like espresso. But if you go to like Starbucks, the venti 20, it's 20 ounces. And so that's also gourmet coffee, which the level of caffeine is like you can't even see my hand, right? Because it's that high. So the venti has like 400 milligrams of caffeine. Imagine just drinking 10 of those a day. Like you would probably, I don't know, it wouldn't feel well. If I drink one of them, I feel like garbage. It's not even like I feel jittery because I have pretty much a caffeine IV. I just feel terrible. So don't do that though. But you can actually have like caffeine tablets. So just keep in mind, regulate. It's not good to have a lot. They are technically toxic. So safety first, then teamwork. Let's see. So for those that are sensitive to caffeine, I have family members that can't even drink like decaffeinated coffee from Starbucks. So technically it does have some level of caffeine, but my thought is maybe there's other like xanthans or like theobromine or theophylline or whatever. Maybe those are in there and like that's not counted as caffeine because it's not caffeine. And so maybe that's what's bothering them because they're very sensitive to those gourmet decaf coffees. But how do you decaffeinate a coffee? Well, we're doing one extraction of caffeine today, right? And so it's done in a similar manner. We can do it with methylene chloride. Remember that time when methylene chloride was an organic solvent though? Not a good idea to really consume beverages after having been exposed to methylene chloride or other organic solvents, because methylene chloride in particular is, it's carcinogenic, right? It's toxic. It's no good for you. But here's the thing. So it's got a boiling point of like 40 degrees Celsius. So remember, give it a warm hug and it's probably boiling off. And so the process of decaffeinating with methylene chloride is done in a manner that should, in theory, get rid of all the methylene chloride because they steam it afterwards. And so, I don't know. I still, when I order green tea, sometimes I get decaffeinated green tea because I like to have tea at like midnight. And you can actually see on there if it's done with organic solvents, or basically they won't say that, they'll be like done with cancer-causing reagents, but or solvents. But what they'll do is they'll say done probably with carbon dioxide, because you can do a really cool carbon dioxide extraction of caffeine from coffee beans as well as tea. And this way is super cool. Hopefully you remember your general chemistry knowledge and the phases of things, right? So we've got liquid, solid, and we've got vapor phase. But then we also have, like on the other side of that curve, that phase diagram, and it goes like, sorry, I'm not sure which direction you're gonna see this. So it's either gonna look like that, or it's gonna look like that. But way off on the side, you have where the line ends, and that's the super critical point. And that point is where you don't have liquid and you don't have a gas. It's got some properties somewhere in between. And CO2 is actually really cool because what you can do is pressurize it, like roll tight, smash it in a little jar, and then heat it up a little bit, depending on the pressure. So if you can pressurize it really well, and then just heat it up with a blow dryer, you're good to go. You'll get supercritical CO2, which doesn't have the properties of liquid or gas, but both. So it has the ability to permeate these tea leaves or the coffee beans, and it'll just swoop on that caffeine, bring it over here, and then it just kind of floats away like a gas. And then you basically came up on some caffeine, right? So, and CO2, even though it has polar bonds, is non-polar because it's linear, right? So you got like pulling both ways, tug of war, cancels out, and so it's non-polar, kind of like methylene chloride. Okay, so, or it's kind of like organic solvents, I should say. So, what else? Oh yeah, there's another way. You can do water where you decaffeinate with water by pretty much making coffee or tea, and then you run that through like charcoal, and then it separates out the components, right? The problem with this is that you're probably separating out some flavor because caffeine is not the delicious flavor that's in coffee necessarily. So with that process, you're going to lose some of the quality of that. But you don't expose it to any harmful, potentially carcinogenic substances. So anyway, that's decaffeination. And yeah, so basically today what we're doing is we're going to brew some tea. Okay. And then what we're going to do is we are going to add some sodium carbonate. The sodium carbonate is a base, okay? That base is going to deprotonate some tannins, which are other substances that are in your delicious tea, right? These are like phenolic compounds that are essentially acids, right? That's why we're throwing in the base, and it's going to deprotonate it and make it a sodium salt, make it super soluble in water, so that way it's not soluble in methylene chloride, and then we only extract the desired compound, and there you go. So after that, we will boil down our methylene chloride, isolating the solid caffeine, and then we will do the sublimation. So super cool. That's all she wrote. So let's do it, yeah? First, what we want to do is figure out how much caffeine we have in here. Oh my goodness, it's about to be a long day, folks. What we want to do is figure out the mass of this, because in theory we should have about 5% of caffeine, 5% of this weight will be caffeine, and so we want to see essentially the percent recovery and assume this. So let's say we had 100 grams of tea leaves, right? That means 5 grams of that should be caffeine, and if we obtain 4 grams, then we have only an 80% recovery, okay? So that's the purpose of measuring the mass of this. So we do have an average. I'll tell you that before I forget. The average weight of the tea leaves by themselves is 0.374 grams. And so that's basically, out of all these bags right now, that's the average mass, okay? So I don't think you really need to see me measure out the mass of this. So let me just tell you what I'm going to do. So here's what I'm doing. Have you ever, hopefully you've had tea before. I don't know. Maybe you haven't. It's really good for you. I should tell you a little bit more about this stuff while I am removing this, but the staple needs to come off, right? And so what I'm going to do is tear that open. Dang, dang, diggity, dang, da, dang. This is like, man. I did a terrible job at that, but that's okay. And then I'm gonna basically just rip this part right here. Boom. So tea bags are actually kind of made in a cool way, but let's see if I can just tap the screen. There you go. The tea was actually split up into 2 little segments, and then it was folded like that. So what I'm gonna do is basically, it's a tube of tea bag. It was a tube of tea bag. And I'm going to pour this out onto some whey paper, measure that, and put that right back in here. and then I'm gonna fold it up, and then I'm gonna staple it shut. I'm gonna fold it, so that way it's like nice and closed, and I don't lose any of the solid tea leaves out from. I don't want them to come out of the bag because it just makes for a mess later. If that happens, it's all good because we're gonna end up filtering, or we can filter. It's not a big deal, but that's how I'm gonna filter it, or I'm gonna measure the mass of that right now. So I'll be back with that number for you. Okay, bye. Okay, so that mass isn't right, what was on that box. So don't even worry about it, because we have actually, that's only for when we're doing this in the lab and you don't really open it up and weigh it. 2.362 grams is what I was pulling out of this bag. I don't know what that's all about, but here's the tube, right? So now I gotta struggle. I'm gonna let you watch me struggle to put this back inside. Woo! There it goes. And ideally I wouldn't spill any of this. In an ideal world, a lot of things would be different though. Boom. All right, that's what's up. I got it. It's almost like I've done this before. Nah, you don't get good at just pouring tea leaves into a opened up bag. So now what I want to do is, I think you're just born with that, you know what I mean? So now what I want to do is actually just fold this up. I'm gonna fold it twice, and then I gotta go grab my string real quick, so I'll be back, and then I'm gonna staple it on there. Okay, so got my stapler. I just wanted to, I don't know why I'm showing you this, but it's cool, I didn't get my finger. I was just playing. Did I get you guys? There you go. It's pretty good. So now what I want to do is basically just boil about 20 mils. So here's the thing. I mentioned it before. Certain measurements in the organic lab matter, and certain measurements don't. Boiling tea, the water is 20 mils, but I just poured 20-ish mils. You can see that it's closer to like 22 or 23, so it doesn't matter because we're just boiling it, and we don't even care about that. Okay, so I'm gonna put this on a hot plate. I'm gonna heat it up, and then once that is hot, have you made tea before? Once that's hot, you're gonna steep your tea. Okay, and then we will go from there. Okay, so just wanted to show you this real quick. First of all, you always want to make sure those lights are on when you turn the heat on. That way you're actually heating the water, because I was sitting here for a hot minute with it just sitting there. But I also wanted to show you this little ring right here. Put this around the beaker just for safety, because although I'm not clumsy, sometimes I have bad days. I might knock that right off. So that's just a little secondary containment kind of thing, helping you out, a little insurance so you don't break your stuff or knock it off the hot plate, okay? Especially hot water. Safety first. All right, so looking pretty good. Now what I want you to do is, basically what you should do is take a look at the volume of this water. It's a little bit above 20, as I said before. We're gonna put this tea bag in here. What you want to do is kind of make sure that that is laying flat on the bottom, so that way we can ensure complete that all of that tea is completely covered. We're gently pushing down with a what is this called? A glass stirring rod, right? We want to make sure that this is not going to kind of bust open that tea bag, because we don't want the tea leaves everywhere, right? But now what I'm doing is I'm going to put this watch glass back on top so we don't lose a bunch of water. And I'm going to keep an eye on the water level, because if we lose water, we want to try and replace that, because you don't want to end up with 5 mils in the end, because that's not going to hold a good amount of caffeine in it, because caffeine is soluble in water, but like not that much is going to be soluble. We want to be able to maximize the amount of caffeine that we extract from these tea leaves, okay? So we're going to let that hang out for 15 minutes, occasionally pushing this that thing down, the tea bag down with the glass stirring rod to ensure that it's completely submerged in water, okay? Okay, so that water level looks a little low. I'm gonna go ahead and, yeah, that's not gonna be pushing down because there's no water, not enough water. Do have a lot on the walls. That was too much. It's all good though. So basically, I'm gonna let that chill for a while, and then what we're going to do is add or take that tea bag out, and then go from there. All right, so I don't want to move the camera, but basically what we're gonna do after the tea is ready, we're gonna place the liquid inside of our centrifuge tube and then shake it up with sodium carbonate. And so what I want to do is make sure that these guys are clean. Okay, so cool thing about this is, well, here's the thing: a lot of students waste their time. I mentioned it before. I'll mention it again. Heating or cleaning these certain glassware and then drying it, right? So why are we going to dry it when all we have to do is, after we clean it with soap and water, we just rinse with DI water, and then we're going to put DI water with tea in it after. So we don't need to dry it. We just move on with our lives. Okay, so there you go, lab tip. Okay, so now what I want to show you is what we're going to do right here is just kind of lift this tea bag up, gently squeeze it out by placing a little bit of pressure on the tea bag with this glass stirring rod up against the glass. Okay, so another reason why this little ring right here is actually helpful, because I can not knock my beaker off and I don't have to touch it because it's hot. But then also I want to point out, remember, you don't want to do it too hard because you don't want to break this glass stirring rod. I've seen it time and time again. Simmer down. Okay, you're gonna be all right. Everything's gonna be all right. Take a breath. Okay. Okay, so now this guy is done. So I'm gonna let that boil off a little bit, just because I got more than I wanted, I think. I'm gonna take a look. Okay, yeah, so that volume is a little too high. I want to try and get that down to around 20 mils, just so I can have about 10 mils in each of these centrifuge tubes, and then have room for the extraction as well, or the addition of methylene chloride. So what I want to do in the meantime, while that's boiling off, is weigh out half a gram, half a gram for each test tube. Okay, so each centrifuge tube, centrifuge tube, and that means a gram total. But here we go. Okay, so what I'm actually going to I'm deciding now to do is, I'm just going to add this gram of sodium carbonate directly to this warm tea, right? What you're going to see, hopefully, is like some bubbles form, okay? And what we want to see also is that stuff dissolving, okay? So let me get that glare out of here. Give it a little swirly swirl. And still on the bottom, it's all good. I'm gonna go ahead and grab that other one. So I weighed out 2 halves, and I'm gonna pour that in there anyway. Okay. Take my glass stirring rod, give it a little gentle stir, not getting crazy. There's a little bit of bubble formation, not as much as I would expect. Remember, that's a base, it's reacting with the acid. So there's, I know you've done this in biology, I gotta remember. So when you're adding, you add, well, I guess it's the other way around, but you add acid to spicula. Did I make that up? Spiculae? Spiculu? Anyway, you're adding it to You can add it to like eggshells or like coral reef or other things in the ocean, and you'll get some bubbles forming, right? What are those bubbles? Do you remember? If you took biology, it's CO2 gas. So a sodium carbonate combined with an acid, or carbonate ion combined with an acid makes CO2 in the water. So that's really what we were looking for here. Okay. It's pretty much dissolved. And now what we want to do is go ahead and place that inside of our centrifuge tubes carefully. Okay. And ideally we would have an equal amount. Okay. I'm going to eyeball this. You may or may not choose to pipette this. So if you are if you're unsure of your ability to pour carefully, then you should use a pipette. So that way you do not spill any of your compound, right? But pipetting is sometimes hard too, right? So you gotta think about that as well. I'll try my best to pour this out, make it equal. The reason why I want to make it equal is because I'm going to be doing extractions, and I just want to add the same volume to each of these and do the same number of extractions and be done. Alright, so that's approximately. That looks really bad in the video just because it's not even, right? It's alright. I'm not mad at it. I'm not mad at it at all. But now we gotta let that cool to room temperature, okay? Because the next step in this is to extract our caffeine with methylene chloride. So we want to make sure that this is not warm, because remember, if you give methylene chloride a warm hug, it pieces out, right? It gets all volatile. Anyway, if you give it a warm hug, it's gonna boil and it's gonna go off. So we don't want this water to be too hot, too warm, because we want it to be just right, which is room temperature, okay? All right, so I put the ice or the tea inside of an ice to cool it faster, and then I also ended up just transferring to 3 different test tubes or centrifuge tubes because there wasn't enough space in there for me. Okay, and now what we want to do is place about 3 mils in each of these, so that way we can do our extractions. So let's. All right, so now what we want to do is cap those, and methylene chloride's kind of a creep. So even though we would have tested these centrifuge tubes for any leaks in the beginning, methylene chloride tends to just kind of go, kind of like a rodent. It's going to go underneath the door, even though you seemingly can't see imagine anything going underneath that door. There's always something small that can fit though. So what we're going to do is go ahead and invert these with the little paper towel on there, so that way if any does leak, it doesn't get on us or our gloves, because these gloves are protective, but they do not, if you do get solvents on them, you should immediately change them, because they're nitrile gloves, and they will acetone, methylene chloride can pretty much go through them, but it just kind of takes a minute. Okay, so what I want to do here is I'm inverting just to make sure that we get a good extraction going. I don't want to shake too much. I do want to mix everything well, but I don't want to shake it too much, because why? Because we don't want an emulsion to form. Okay, and so if that happens, then we're going to have to go ahead and put this on in the centrifuge for a few minutes, and ain't nobody got time for that. But no, sometimes it is good to just be patient, take the time to do the centrifuge or the other things that might take a little bit longer, so that way you get better results in the end, because you can't rush chemistry. Okay, so we didn't really get anything on here, so that's good. Now what we can do is go ahead and uncap all of these. I'm going to go ahead and use the paper towel still, because, yeah. Place that, set that down. Go ahead and uncap that guy. And then this last one right here. And we're gonna let that hang out for a second just to kind of more or less settle. So that way I can extract the methylene chloride layer. What's up? Methylene chloride layer. And place that inside of a 25 milliliter Erlenmeyer flask so that I can boil it down. Okay. Okay, so here's a layer of methylene chloride. Here's the container that I want to transfer it to. So I'm going to go ahead and hold these, remember, in one hand with multiple fingers. And what I'm going to do now is go ahead and place this pipette inside of the centrifuge tube to withdraw the lower layer, because that is a more dense methylene chloride layer containing our caffeine extract. So one of the things that I saw a lot in is basically when you dip that in there, you can even see it on the bottom of this. Sorry, I got all kinds of. You can see that the pipette has, the tip of it has a little bit of that water layer in it, right? But here's a little trick. You can actually just blow air through it and that gets rid of it. So now what I'm doing is I place it in there, blowing bubbles to get rid of any of that stuff that I don't want, because I don't want that water layer. And I'm squeezing it to the point where I feel like when I let go, I will withdraw methylene chloride to whatever extent that I want. Okay, so if I want more, I can blow more bubbles. Okay. There we go. Now I'm gonna do squeeze the bubble, or the pipette. Sorry, the pipette bulb all the way down, because I think I want to get all of that liquid on the bottom. And oh no, look at that! I got stuff in there. Oh no. Well, that's not a problem. I could just kind of squirt that back in there. I could technically start over. So what that tells me is that I squeezed it too much, right? And so now I know that maybe I gotta squeeze it maybe halfway, and then I'll get the amount of, I'll get the methylene chloride that I want. Because when I release it completely, it's a lot easier than it is to partially, when I release it completely, it's easier to lift it up than it is if I only partially release it, because then I have to keep a steady hand, and then that kind of jumping can happen, and it just gets really difficult to kind of come up without withdrawing any of that water layer. Okay, so that's just a little tip for you on extracting liquids. So I need to get a new pipette because I have water in that one now. Okay, so be right back. All right, so here we go. I'm going to squeeze it halfway while going down so I get those bubbles out. Now I've completely released. Okay. And now I got a little bit of water in there, but I could just let that drip a little bit. Okay. Now I'm going to go ahead and squirt that out. And there you go. Do it again. It looks like that water is getting mad at me right now. The cool thing is that, see how it's kind of sticking in the pipette? It's all good. We don't really have any in here, okay? And then I can squirt whatever I want back in here. Okay, so I'm basically gonna do that for all 3 of these, and I'm going to do it twice. So you don't wanna watch that twice. It's kind of boring, but just now you have the info you need to successfully extract the caffeine with methylene chloride, okay? I'll see you when I get all of the organic solvents inside of this Erlenmeyer flask. All right, so we've transferred all of our organic layers into one flask. You can see that we have some So let's put it over here. Some of my brown solution, that's the water. Basically what we want to do is transfer this to a clean flask so that we don't have that organic layer or that water layer in there. Jeez, this is ridiculous. So actually I might be able to just decant this instead of pipetting 87 times, because that water layer, what's cool about that is that it likes to stick to the glass when it's in solution with, or when it's mixed with like methylene chloride, for example. So I could just pour this out. Boom. Check that out. Now it's all stuck to the, you can still see it's stuck to the glass, and this guy is nice and clean. So now what we want to do is place sodium sulfate into here to let that dry, essentially getting rid of any residual water that might be left in here. And then we can transfer that and boil down. All right, so I pre-weighed a 25 milliliter flask, Erlenmeyer flask, so that I could transfer the clean and dry methylene chloride layer into there and then boil it down. But what we want to do first is prepare a pipette like filter, so that way when I transfer the methylene chloride I won't really have any issues with transferring the solid material as well. So I put a little bit of cotton right there. I'm choosing to use the shorter one right here because when you place it inside of the flask like that, it doesn't have like a really long stem that's really thin and easily broken. This one right here, this is just ready to just snap, right? And then have glass shooting up somewhere, right? So that's personal preference. I like to use these short guys for that purpose, okay? Okay, so now I've had this methylene chloride sitting with the sodium sulfate for probably like 5, maybe even 10 minutes. You can see that it's basically, when we swirl it, we got like, we're snow globing, you know what I mean? So that's a good dry solution here. Now what we want to do is put your hands really close together with them, so that way the transfer is minimal in the amount of distance we have to go. So I like to just set this one right into the flask that I'm transferring to. And I might actually just hold it down here. I don't even have to hold it and you guys can still see it, so that's perfect. But now, that's the hard part right there. Getting it inside of that pipette without spilling, right? Or you gotta make it inside of there before you actually let the methylene chloride come out. You also want to make sure that you have, when this is kind of in there, you want to let it equilibrate, let the vapor pressure of that methylene chloride kind of take over the inside so that you don't force anything down. That way when you lift it up, you can easily just place that inside of your pipette, okay? So we're going to do this a bunch more times until we've got all of our methylene chloride transferred to this here flask. So you can see gravity is doing a great job at kind of just letting that methylene chloride go through, so I won't bore you with the rest of this transfer. Okay, so now that's all transferred, and what I want to do just to make sure that we get all of it out is put that pipette on top of there. You see how someone's just chilling right at the top? Go ahead and give that a squeeze. Remember, since we're done, we can just kind of take this out. But we also want to remember, in a typical transfer, if we're not choosing to be done here, we want to use that pipette filter still. You want to pop this bulb off first and then unsqueeze, okay? But all is good in the world. No solid in there, and so now I can place this on top of, on the hot plate, so that way we can boil off that methylene chloride, and then once we get that, we will see what our solid is. What's up, y'all? So what you can see is I got my methylene chloride flask chilling right here. Let's put that in the hood. Yep. So what you want to do now is place that in your hot water bath, maybe like 45, 50 degrees, just nothing too out of control. You're gonna hold it there until everything is boiled off. And you wanna make sure that you don't heat it after all the solvent's gone, because remember, caffeine can not only burn, but it can also sublime. So you're going to lose some product, okay? And I'm not going to bore you with the details of that, right? You've seen this before. You know how to do it. You don't want to watch me boil off solvent, right? That's like watching paint dry. So you know how to do this. You want to make sure that you're swirling it regularly or constantly, because methylene chloride is really fast. It goes away fast. And so, yeah. All right. We'll see what I'll see you when we get the solids. Oh, we all done now. Yes, queen. So we got our methylene chloride's all gone. We got our solid chilling right there. I'm gonna let that sit in the hood to cool down to room temperature, because remember, warm hugs make methylene chloride vaporize, and we don't want any residual methylene chloride vapors to kind of come into the lab and get into our lungs, because remember, it's toxic, carcinogenic. It's it's just all no good. All right, so sit tight. All right, so I wanted to point a little something out. You can see, you probably can't see. Oh, you see how that kind of looks like a fog? Well, see, what had happened was I went ahead and clamped that to the hot water so I can get a snack. It wasn't even on the hot water, actually. It was way above it, but you can still feel the heat. Basically, water gave it a nice and warm hug. And when I came back, after I had eaten my snack and hydrated, it looks like some of that caffeine was trying to leave. So remember, I did say that you want to be careful with not overheating it when you get the solid. Basically, you get the solid, you're done, but I had to get a snack. I was dying. So, and I made sure that when I left it, it was in a safe and secure spot. No methylene chloride would kind of bump or anything like that. It was good to go. It was basically just sitting like with like some hot breath on it. You know what I mean? So too much hot breath though, and it looks like some of it tried to leave, and then even on the tip at the top, you can see some got out, but that's okay. So what we're gonna do now is go ahead and measure that. I'm just pointing that out because, hey, that seems like it's a potential error, right? Methylene chloride, or I'm sorry, caffeine sublimes, and it probably sublimed away. So that says 23.739 grams. Okay, so don't forget, I already gave you the mass of the flask, right? So you just find the subtraction, or find the difference. It was 23.723 grams. Okay, now we've got to move on. What we're going to do now is place methylene chloride in here. We're going to transfer it for the sublimation. Okay, bye. Okay, so I got some solid in here. Now I need to transfer that to a 5 ml conical vial. So what way I need to do this is, fortunately, I got to redissolve this bad boy down, about a 1/2 ml of methylene chloride, and then make sure we boil that off. Okay, so what I'm doing now is kind of just making sure that I got everything dissolved before I transfer that, and then I can go ahead and be done. So there's a little bit of like stuff on here on the rim, but I don't think I'm going to be able to get that. So we're just going to call that a loss. Take the L on that for sure, but that's okay, because we've got plenty more over here. Or maybe I can yeah, no, that's not going to work. So now that I've got it inside of this conical vial, I'm going to go ahead and heat this conical vial up, kind of like I did this flask. But be more careful so as not to lose any material. You can see it just kind of boiling in there, chilling. Nothing too crazy, not out of control. Definitely a controlled boil. We don't want it to get too crazy, so that way if it pops, for example, like splatters, then we'll lose material like that. So we want to make sure that we're also kind of giving a little swirly swirl occasionally, and that's about it. So see you when solid comes. All right, so that solid actually came pretty fast. Out of nowhere, it just kind of is there. And so what we're gonna do again is let that hang out on the bench top until it cools to room temperature, okay? Now that's it. Okay, so now what we've got here is our nice lovely solid right here. You can't see that because my finger's there, which is also a solid. So, I mean, I wasn't wrong. This is the sublimation apparatus, like the rest of it. So we're using this conical vial, 5 mils. We're using this, and it has a cold finger on there. So what a cold finger is it's a thing that kind of protrudes inside of this flask, or this conical vial in this case. And we make it cold by adding cold water, ice water into here. You could do colder things like acetone and dry ice, that's negative 78 degrees Celsius, or you could even do like liquid nitrogen, that's a negative 196 degrees Celsius. But your cold finger is basically gonna have some cold stuff in it, right? And so the purpose is because as we heat this under vacuum, so here, let's check this out. Yeah, we got a vacuum, y'all. Now what we're going to do is put this on, and I'm gonna slowly pull the vacuum because I don't want any of my solid to kind of fluff up and fly away. So now we got that going. Now that we're under vacuum, we're under reduced pressure. Now we have a state or a kind of like an environment that allows the caffeine to sublime more easily. And so what we're going to do is put some ice water in here. We're going to heat the outside of this conical vial. That's going to force the caffeine to go from a solid to a vapor, which is sublimation, and then it's going to hit that icy cold finger, and it's no longer going to be hot. It's still going to be under reduced pressure, but it's not hot anymore, so it's not in that state where it can sublime. And so what's going to happen is, ideally, that solid material, the caffeine, the good stuff, you can see this poopy brown stuff in there, right? The good stuff is going to sublime and then condense onto that cold finger as just pure, beautiful, gorgeous caffeine, okay? So let's go ahead and add some water to this. This is some icy water. You can see we got that good condensation going, okay? So I'm gonna let that hang out for a minute while I set up my Bunsen burner. Okay, so you can see this beautiful blue cone right here. That means I'm good to go. So what I'm gonna do is just heat this. I'm gonna run the flame over the conical vial like this, just back and forth, back and forth. Try and hit those angles just to make sure that we get everywhere nice and uniform. And so we can, and then what I'm gonna do is hit it with heat. I'm gonna take it off, let it like kind of almost like equilibrate, and then see what happens, and then go again, okay? So we'll see. If you're wondering what the heck I'm doing, that's what I'm doing. So back and forth, back and forth. I don't want to, here, let me move this a little bit. See, can you see that well? There we go. Boom. All right. Let's see. We don't have much action going yet. So we just kind of let it keep going. Be patient, okay? It's tough being patient when you've been in the lab for like 3 hours, and you're like, I want to go eat food or whatever, and or I gotta go home and take a nap or sleep, but you don't want to waste that 3 hours, right? So you want to make sure that you are patient. Now I can start to see. I can see a little bit of solid material on that cold finger, okay? So what I like to do personally is, because I don't have any ice in there, and cold ice, or water really isn't that cold. Or, I mean, really isn't that cold compared to this flame right here. So I like to replace that cold water sometimes. Just depends on how long the process is taking. This is kind of taking a minute, so you know, it doesn't hurt, right? Easy fix, just pipette. Fix it up, fix it up. Woo! I see it. I don't know if you can see it. I'm gonna turn my flame off just so that we can take a look closer. Let's see. I know you could see that. Look at that. Ooh, that's pretty. All right. See, it's starting to get that solid on that cold finger, and that's what we want. that's really what it's all about. Okay, so we'll just keep doing that until we feel like we've either got all of the solid material off or it explodes. No, it won't explode, but you could end up like burning the material or something, and so we don't want to do that either. So we're gonna, again, be patient, continue to heat, but I don't know exactly how long this is gonna take, so I'm not going to film the entire process. I think you've got enough of it. If we have more material in there, you'll get a lot more material on that cold finger much quicker, but as you saw, we only had like, I don't know, what was it, 30, 40, no, probably like 20 milligrams, something like that. So we don't have a ton, so we gotta be patient and endure, okay? I'll see you, I'm gonna bring it back when we get all of this ore and I decide to be done, okay? Oh yeah, check it out. We got some solid, kind of like, just like sticking out on the top and the bottom, like, whoa. Actually, not the top, just the bottom. Yeah, so I think we're almost done. You can see that down here, there's not really much going on. So I really just want to get that far end, so I have to move this guy so that it's within range of this hose. All right, and now, I don't know if you might not be able to see it, but there's like some melting going on. And so this is a great stopping point for me, personally, and so I'm gonna let that hang out, because this is like straight up hot lava now, because I was, right, fire's hot lava, temperature pretty close, yeah. So we don't want to touch that. We want to let that hang out and cool for a minute. So I'm going to clean up all the stuff, all the things, make sure the waste goes in the proper waste container, and turn that off real quick. And yeah, we make sure that we leave the lab cleaner than it was when you got here, I think. So also, I didn't tell you, but I grabbed one of these guys of the crude material before sublimation. So it had some of that poopy brown in there. So we're gonna take a look at the melting point difference between this guy, crude, and that beautiful, gorgeous caffeine that we sublime, and see if there is a difference. Maybe there's not. Maybe the extraction was good, and I don't know. So we'll see. Bye. Okay, so it's been cooling for like a long time. So here's the thing. I'm gonna tell you this one time. Okay, pipette that liquid out of there. Okay, get that right out of there, because what's gonna happen is, so this is water, so I'm going right down the drain with that. And what's gonna happen is you're gonna take this off, you're gonna start manipulating it, you're gonna move it around, and then you're gonna be like, splash! Water all over your caffeine. It's gonna ruin your day. It's probably gonna ruin my day by proxy, right? Because you're gonna end up being in the lab a little bit longer. JK, joke. I'm here for 4 hours for y'all. Okay, whatever you need. 24/7 too. Hit me with an email. I got you. Just playing. A joke. I kid. So now what you want to do is turn off. But yeah, seriously, just get rid of the water, because then you don't want to ruin it. We'll help you troubleshoot if you ever run into problems. All good. It's gonna happen. It takes experience, right? You got to think about all those potential issues when you're moving forward. Okay. So now we also want to be really careful when we're taking this cold finger out, because it's got all that lovely crystalline solid on there, right? So when we lift it up, we don't want to be like, whoa, and then bang it on the side so that it falls off. So first things first, you're not going to get that off if you don't release the vacuum. So you turn off the vacuum. Now here's the thing. You could technically pull that vacuum off from the wall, but what's going to happen is it's going to suck air in. And that tube, I mean, you can see that's poopy brown right there. It's all kinds of, it looks like a burnt hot dog. And you don't want burnt hot dog juice all up inside of this right here. Okay, so let's do, sorry, I threw myself off with that garbage, with that silliness. So what we're gonna do is take it off from here. And what I like to do is I twist and I pull. slowly, okay? Once you get to the end, crack it like a soda pop, okay? You just, you hear that? You hear that or Alicia? I don't know. Now gently let air in. And so now what I can do, this might still be hot lava. So I'm gonna make sure you're careful, because you never know. Assume, oh, I don't know if I told you this too. Hot glass looks just like cold glass. I don't know if you knew that. So be careful. Assume it's hot, okay? So now I'm gonna take this straight up. Ooh, just got shaky hands right now. And now what we're gonna do is scrape this off. And we're gonna scrape that off. Here, I don't know, I can't get the video to be like autofocus on your good stuff. So basically we're gonna scrape that off onto white paper that we have teared, okay? So that way we can get the mass of this material. Okay, I know there's the hot dog right there, but don't worry about that. I'm literally using that to prop up. So here we go. This is me scraping off this solid onto here with a spatula, right? Ooh, look at all of that. Like, why did we, oh my goodness, it's so pretty. So this is actually part of the reason why when you have dark roast coffee doesn't have as much caffeine because you roast it longer, right? And if you're heating that bad boy up, you're losing precious caffeine. That's why you want to go with the lighter roast to get that pick-me-up. But it does obviously give you a little different flavor, so go with both because they're both delicious. All right, so sometimes you just gotta call it a day. Like this powder is like sticking to it like crazy. But I do have a significant amount of solid left on, or not left on, but on my actual like white paper. So I'll do one last little rotation around this and then we will call it a day. I'm not too crazy. As long as we got a good enough amount to analyze via melting point and whatever else you got to do, then we are good to go. And we are in this case. So, but there's definitely a point, an area where we might have lost some. We definitely lost some. Look at that. I'm leaving that. It's gone. Okay. Another thing. Don't be running around the lab with this all just open out and about. Somebody gives a sigh because they lost the material, blow your stuff away. Or like sneeze or just walk fast, a gust of wind through the window will blow this material right off. Okay, look at that. Oh, there it is. Oh, there it is. Let's go. Let's see how much we got. Okay, so I told you I already teared this. Since I'm in here all by myself, I just came to the same scale, and I didn't have to do anything, right? So this says, oh, it's moving around a lot. We'll just call it 12 milligrams, 0.012, and that's it. So now what we're gonna do is we're gonna go ahead and get a melting point. And we're gonna get the heck out of here. We're gonna get a Red Bull, probably 2 of them, because I got the 8-ounce ones, and some water, a snack. What time is it? Oh, I left my watch at home. I don't even know what time it is. Okay, that's it. Okay, so trying to put this in. Sometimes you gotta turn it sideways and give it a gentle flick to get that stuff down, even after tapping it like so on the bench top. Okay, now looks like I got enough. Okay, so what we're gonna do is go ahead and get this bad boy started. So I planned ahead because I'm an adult, and I got this started already. Got the start temperature at 200, ramp rate at 5, 250 for the top, and let's go. So the good stuff, I'm gonna put it on the right side because I don't know, like that's the right stuff. You know what I mean? That's how I remember stuff. So now what we're gonna do is go ahead and take a look-see inside, and yeah, go ahead and click start. And there we go. It should be melting now. So what I'm gonna do is hold on. I'm falling. I'm sorry. Okay, so we are going up steady and surely. So what I want to tell you is the stuff on the left is the crude. Stuff on the right is the pure. One of the cool things about sublimation is that let's say like one form of purification or one way we purify something is by crystallizing it, right? So put in some solvent, heat it up, boil it down, let it crystallize out, then we filter it, let it dry. Well, the cool thing about sublimation is that we actually don't have to let it dry because it was under vacuum in heat. And then it went to the vapor phase and then to the solid phase on that cold finger. And so this stuff right here on the right, the caffeine is just good to go. It's likely the stuff on the left is dry in this case as well because the caffeine was just in the presence of methylene chloride, which is boiling point of 40 degrees, remember? Right now we're chilling at 206, and so that's significantly higher. So that methylene chloride is gone, okay? But again, the cool thing is, that might not be the case for some things, right? So if we chose to crystallize caffeine like we did in a previous lab, we would still have some residual solvents, and that might affect the melting point, and we'd be so sad. Okay, so let's take a look at this particular melting point when we got super dry, super clean caffeine. And yeah, so that's definitely just one of the benefits for melting point, for sublimation, and we don't have to use. We're saving cost on solvents, right? And so that's just across the board. We're saving cost on solvents. We aren't using harsh organic solvents, so those aren't trash. They're not worsening the environment, et cetera, et cetera. And so, just what else would there be? I mean, it's pretty simple. It was very fast. You saw portions of the video of me doing it, but that was really only like not even a 5-minute process, the whole thing. And so that's not, obviously it's going to be a lot longer when you do, it's going to be a lot longer process when you have more material, because we had like apparently 12 milligrams. And so there might be a little bit more than that, but that scale was a little janky. But yeah, so I mean, I've done 50 grams of fresh sublimation in grad school, and so that definitely, we just left that for like 4 hours or 5 hours or overnight, and so we'd come back and we'd be like, boom, beautiful material, and that was it. So yeah, that's pretty much it for now. I'll let you know when we start seeing a little something, what temperature it is. Right now we are at 215.9, 216. Nothing going on, okay? All right, let's see if we can't zoom in. I would say, okay, so this temperature right here is 218. Maybe a little something going on here. I'm gonna try to let you guys just decide what you want to do. Right now we're at 219.4. I'll just keep counting numbers off while you observe. Try my best to keep it steady. 220.2. Okay, let's see. We've got now we are at 221. If you haven't figured it out, you should fast forward this video for sure. But listen to all the stuff that I say in the previous like couple minutes, right? We're at 222. Going on. 223. Bam, bam, bam. 224. And this looks pretty. It looks kind of like some Christmas going on here, huh? Is it Christmas time already? Oh, it's not even Halloween yet. What are you guys gonna do for Halloween? Nothing? How to Halloween in pandemic. Just watch movies, eat candy. Ooh, that looks like some tinsel. To me at least. I don't know, I might be tripping because I'm staring at this screen so long. We're at 226.5. I don't know what that brown booger is. I don't want to move the video though because we're getting close. 227.3, that brown boogery looking thing on the upper right. That's been there for a minute though. Ooh, I see stuff. 227.9. Looks like it's turning. I'll let you decide. 222 or 228.3.4.5. Now we're at 229 now. We're at 229.4, 229.7, 229.9, 230.2, 230.4, 230.7, 230.9, 231.3, 231.6, 231.8, 231.9, 232.2, and we out, right? You agree? Okay, I'll just 232.7. How about that? Okay, bye. Yep, there we go. Tell me what you saw. Bye. Hopefully you remember what the melting point process is all about. So remember, we got to remember terms such as shrinkage. We got to remember the melting point range is important. First drop of liquid to the last drop of liquid formed in no more solid, right? And then we also have decomposition as a possibility. Think about, yeah, I don't know. There's a lot. There's video out there for you. I've seen it. Go ahead and check it out. And what I'm going to do is go ahead and make sure that I get this stuff in the waste container, and then I'll be on my way. Bye.